So similar to section 3, when we looked at sampling distributions for a difference in proportions, we're going to do the same thing in section 5, but for means. So for each population or treatment, so our two populations or treatments, we're going to have a population mean and a standard deviation mean. So a mu1 and a sigma 1. And then the second group will have its own mean and standard deviation, which then means we'll have our two test statistics, mu sub x1 and then sigma sub x1 bar, and then mu sub x2 bar and sigma sub x2 bar. And then we'll also have our sample sizes N1 and N2. So we have to check our conditions for a difference between two means. So the nice thing here is if the population distributions are normal, then the sampling distribution for their difference is also normal. So if I'm told that both population distributions are normal, I don't need to check the sample sizes. If we do not know that the difference will be approximately normal, we have to check that N1 is greater than or equal to 30 and N2 is greater than or equal to 30. For the center, so for my mean, if I'm taking two random samples, so I'm taking an SRS, or I've randomly assigned to two groups doing an experiment, then the mean of the difference is going to be equal to the mean of whatever you get when you subtract the two sample means, similar to proportions. For the spread or our standard deviation, if we are sampling without replacement, we need to check the 10% condition on both distributions, not just one. So similar to how we had to check the 10% condition for both for proportions, we have to do the same for means. Now, if it's an experiment, we don't need to check because experiments are always going to be independent. Now, the standard deviation formula for a difference in means is actually not that similar to the standard deviation formula for a single mean. It's more closely related to when we were looking at a difference comparing two distributions. It's a lot more similar to that formula. So we're actually going to do the square root of standard deviation 1 squared over N1 plus standard deviation 2 squared over N2. So very different than just your normal standard deviation formula. Okay, so let's do a couple examples. In our first example, we have that the mean height of 15-year-old boys in centimeters is 175 and the standard deviation is 8. For girls, the mean is 165 and the standard deviation is also 8. If 8 boys and 8 girls were sampled, what is the probability that the mean height of the sample of girls would be higher than the mean height of the sample of boys? Verify that you can construct a sampling distribution for a difference between sample means. So that last sentence is just check your conditions before calculating the probability. So the first thing I actually need to do here is define what x1 and x2 are going to be. Because if it's not already defined for you, you have to choose, which can affect how you set up your probability statement. So it's very important you identify that ahead of time. So I'm going to let x1 be the height of the boys and x2 be the height of girls. So for my probability statement, if I want to find the probability that girls will be taller than boys, then their difference, x1 bar minus x2 bar, would be negative. It'd be less than 0 because the girls are going to be taller than the boys. So first I'm going to check my 3 conditions. First I'm going to check random. which we're going to go ahead and assume here that when we selected our 8 boys and 8 girls, we did select them randomly. For independent, my sample size 8 has to be less than or equal to 10% of all 15-year-old boys, which there's at least 150 of those. And then I also have to check that 8 is less than or equal to 10% of all 15-year-old girls, of which there are also at least 150 of those. And then lastly, I have to check normal. Now, it does not state in the problem that my population distribution is normal. So I would have to check my sample size. And unfortunately, my sample sizes are both 8, which is not greater than or equal to 30. So my distribution is not normal. So I have not met that condition. I'm still going to go ahead and find the probability. However, I know that this probability is not likely to be something that I would use for my population because my distribution is not normal. So I would want to if I wanted to make an inference about the population, I would want to redo this either knowing that my population distribution is normal, or I would want to take a larger sample size. So the mean of our distribution, we're going to do 175 minus 165, which is 10. And then for our standard deviation, we're going to do the square root of 8 squared over 8 plus 8 squared over 8. Because not only are both of the standard deviations 8, but the sample sizes are also 8. And we're actually going to get an exact number here of 4. So now we're going to do normal CDF. The lower bound is going to be negative 1e99. Our upper bound is going to be 0, mean of 10, standard deviation of 4. So we plug that in our calculator. We are going to get 0.0062. Very, very small probability, less than 1%. So for our sentence, the probability, the mean height of girls is higher than the mean height of boys is 0.0062. Which again, since I don't have my normal condition, I wouldn't really use this to make any conclusions anyway, because it's not a normal distribution. So let's look at our last example. So we have an electrical appliance made by a company A that has an average lifespan of 2,500 hours with a standard deviation of 500 hours. Company B makes this appliance with an average life of 2,300 hours with a standard deviation of 800 hours. We're going to take 300 Company A devices and 200 Company B devices, and we want to calculate that the average life of the sample from Company A isn't 100 hours more than the average life of the sample from Company B. So I'm going to have X1 be Company A and X2 be Company B. Okay. So for my probability statement, I'm looking at the difference in their means, and we want to check that the average life from Company A isn't 100 hours more than the average life of sample B, which means that their difference is less than 100. So a little bit different of a problem because we're not specifically looking for one of them to be bigger than the other, in which case our difference would be either positive or negative. We're looking for it to be less than or greater than a specific amount. So for random here, again, we're going to go ahead and assume that when we took our appliances from each company, we selected them randomly. For independent, we took 300 appliances from company A, so 300 has to be less than or equal to 10% of all appliances from company A, which we'll go ahead and assume they make at least 3,000. And then 200 has to be less than or equal to 10% of all appliances from company B, which we'll go ahead and assume they make at least 2,000. So even though 200 and 300 aren't the same here, they are pretty close in sample sizes, so it's not too big of a difference. If I had been looking at like 400 and 200, I would probably take this with a little bit of a grain of salt. And then lastly, for normal, we don't know that the populations are normal, so I do have to check that both sample sizes are greater than or equal to 30. And 200 and 300 are greater than or equal to 30, so we're good there. So now I'm going to calculate the mean for the difference in my sampling distribution. So we're going to do 2,500 minus 2,300, which is going to give us 200. And then for our standard deviation, we're going to do the square root of 500 squared over 300 plus 800 squared over 200. And we're not going to get an exact standard deviation here. We're going to end up with 63.51. So now we're going to go to normal CDF. My lower bound is going to be negative 1E99. The upper bound is going to be 100. The mean is 200. And the standard deviation is going to be 63.51. And we're going to get a probability of 0.0577. So for our concluding sentence, we'll say the probability the average lifespan of the electrical appliance from company A isn't more than 100 hours from company B is 0.0577. So not a very high probability. Pretty low chance that it isn't more than 100 hours. Which probably tells us that the electrical appliance from company A does last longer than the one from company B. So let me know if you have any questions about difference in sampling distributions for a difference in sample means.